digital carrier modulation. To transmit baseband digital information over a satellite link, digital information is converted to a carrier frequency at a suitable bandpass channel frequency of the spectrum, known as digital carrier modulation. The modulator is an earth station equipment that receives the symbol stream of data from the encoder and uses it for the modulation of intermediate frequency, IF, carrier. The IF carrier is selected for modulation than satellite RF uplink frequency because it is challenging to design a modulator that modulates Q and C bands frequency spectrum 6 or 14 GHz directly. In M-array modulation schemes, the output of the encoder used to select in the sets of k digits available, each k digit set or symbol is utilized to choose one of the AM waveforms. The modulated IF carrier from the output of the modulator is transmitted to up converter, that is buck, which translates the intermediate frequency, IF, to uplink RF frequency in the uplink spectrum of a given satellite. The modulated carrier after that is fed to a high-power amplifier, HPA. HPA amplifies the modulated RF carrier to an appropriate level for transmission by the antenna to the satellite. The modulated RF carrier is received by the antenna of the earth station on the receiving interface of earth station and downlink frequency footprint of a given satellite. The received modulated RF carrier has a low level, a low noise amplifier, LNA, amplifies this low-level RF carrier to retain the CN at a level required to justify the error rate requirements. The amplified carrier is fed to the down-converted from LNA output and translated from RF carrier to intermediate frequency. The reason for down-converting from RF to IF is that it is very much easy to design a demodulator for IF than RF. The modulated IF is routed to a demodulator which extracts the information, which is fed to a decoder which performs the function opposite that of the encoder. After decoding, the data stream is routed to the baseband equipment for further processing and then delivered to local networks. Orthogonal polarization is one of the methods to obtain frequency reuse. In this method, two signals are transmitted on same frequency band by assigning each on an orthogonal polarization. In this way the information capability is doubled by the satellite and the best level of isolation between the two polarizations is required in dual polarization transmission so that co-channel interference is acceptable.